Hello everyone. Welcome to Controllers Tech. This video is the start of a new series, which will focus on the dual-core processors by ST. We will cover a lot of things here, some of which are unique to these microcontrollers, like inter-CPU communication, or hardware semaphores, etc. So let's start with the first step, and that is, getting started with STM32 dual-core processors. This video will cover the basic things, like how to create project, how to debug both the cores simultaneously, and how to turn off second core. Here I am using STM32H745 discovery board. It have a Cortex M7 MCU, and a Cortex M4 MCU. You can see it have a LCD attached to it, so a tutorial on LTDC will be coming soon. Let's start by creating a project in Cube IDE. Select the microcontroller. Give some name to this project, and click Finish. Here you can see, two different projects got created for M7 core, and M4 core. Here is our Cube MX. There are a lot of pins here, and they are initialized in their default states. Let's clear this pin out first. First of all, I am selecting the external crystal for the clock. This is valid for both M7 core, and the M4 core. Let's go to the clock setup now. This looks huge. Let's select PCLK, and try setting up the clock at 400 MHz. It's showing the error. No problem, we will do the manual setup. Let's divide it by 5, and then multiply by 160, and we got the 400 MHz clock. M4 core can run at maximum 240 MHz, so we will divide here by 2. Also use the prescalers of 2 here. Everything looks good now. In case you want to run it at maximum 480 MHz, all you need to do is change the multiplier here to 192. And now the clock is at 480 MHz. In case you keep getting error, make sure this voltage scale is selected least here. In my case it is set to scale 1. Also supply source should be direct SMPS supply. Let's enable the cache for the Cortex M7. We will not be using MPU anytime soon. I am going to blink the onboard LEDs today, so let's take a look at the schematics to find out where they are connected to. You can see we have two LEDs here, LED 1 is green, and LED 2 is red. LED 1 is connected to pin PJ2, and LED 2 is connected to pin PI13. So let's search for these pins, and select them as output. Let's see the GPIO setup now. Here you see the pin context assignment is free by default. This means that the pin is not assigned to either of these cores, and we can manually add them later. But we will not do that, and we are going to assign each pin to the individual core. I am assigning PI13 to the Cortex-M7, and PJ2 to the Cortex-M4. Basically that's how every peripheral is. You can assign each peripheral to the individual core. You have to turn the peripheral on for the respective core, and then set it up. We will cover those things some other time. That's all for the setup. Click Save to generate the project. This main file is for the M7 core. And this one is for the M4 core. Note here that the system clock is configured in the M7 core, and not in the M4 core. So it is necessary that the M7 core runs first, configures the system clock and all other necessary configurations, and then the M4 core can run. To make this possible, these steps are pre-generated in the code. Here the CPU1 waits for the CPU2 to go into the stop mode. If you look at the CPU2, as soon as it boots, it enters the stop mode. After that, CPU1 initializes the system clock, and other necessary things, and finally it releases the hardware semaphore. CPU2 on the other hand, before going into stop mode, activates the notification for the semaphore. When it receives the notification, it wakes up from the stop mode, and the rest of the code starts working as usual. CPU1 also waits for the CPU2 to wake up. This is how both the cores initializes. Note that the pin PI13 is initialized in the M7 core, just like we set up in the CubeMX. In the while loop, we will toggle this pin every 500 milliseconds. Similarly, in the M4 core, we will toggle the pin PJ2. So that's it. Let's build it now. We have to separately build both the projects. Let's debug them now. This part is very crucial, so pay attention here. Right now I have selected the M7 core's main file. Go to Debug Configuration, and double-click here. It will generate a debug configuration. Note here that this is for the CM7. Go to the Debugger tab. Keep in mind what is this port number for the GDB. Here we have Cortex M7. Check this halt all cores. This will basically halt both the cores, and that way CPU2 can't run on its own in the beginning. Shared ST link must be checked. Now go to Startup tab. Here we have the configuration for the CM7. Click Add, select CM4, select Debug, and click OK. We are doing this because we want the Cortex M7 configuration to build, and load the code for M4 also. So that we don't have to load the code separately using the M4. Now click Apply, and click Close. Now we will create the configuration for the Cortex M4. So go to the main file of Cortex M4, and click Debug Configuration. Again double-click here, and it will generate the configuration for the M4 core. Go to Debugger tab. This is the same port number as for the M7, so we will increase it by at least 3. Under the reset behavior, select None, as we are already halting both the cores using M7. Go to Startup tab. We are already downloading the code using the M7, so we don't need to do it here. Select Edit, and uncheck the download option. Click Apply to save this. Now we will first launch the debugger using the M7 configuration. Once we are in the debugger, again launch the M4 configuration. So here we are, both the configurations are loaded successfully. Here you can see both the main files, and we can switch between them, depending on where we want to be. Let's set a breakpoint here, before initializing the pin. I am setting it at the same statement, in the M7 also. Now select both these with Control button, and click Run. We need to run them together, or else it will stuck. It hit the breakpoint in the M4 core. If we go to the M7 configuration, you can see, this is also waiting at breakpoint. Keep checking the LEDs on the board. I will go to M7 file, and step over these statements. Notice that only the red LED is blinking as I am going through the statements. This means that the M4 core is still waiting at that breakpoint. We will keep this red LED on, and go to the second core. And as I step over these statements, only the green LED is blinking. So here we are able to debug the cores separately. Let's run this code now. Since I am running the M4 code, the green LED is blinking, while the red one is still on. Let's stop this one, and run the M7 core. And now only the red LED is blinking. If you want to run both of them, you have to again select using the Control button, and then hit Run. Everything is okay here, but the problem is that you can't reset a single core. Whenever you want to reset, you have to do for both cores. And even after that, if we run it just like we run initially, this time the core 2 will not stop at the breakpoint. You can see that the core 1 has stopped at the breakpoint. But this is not the case with the core 2, and it is still running, as you can see the LEDs keep blinking. I don't know why this happens, and if anyone have better idea, please comment below. Anyway, we can stop the core 2 manually. This is it for the debugging part. Now let's say we want to run only one core, and don't want the second core to consume power unnecessarily. In that case, we must stop the second core from booting. This can be done by modifying the OptionBytes. And to do this, we will use the STM32 cube programmer. Connect the device here, and click OptionBytes. Here in the user configuration, you can see the bits BCM4 and BCM7. These bits controls which CPU will boot, and which won't. If I uncheck this, that means the M4 core will not boot. Click Apply to save this. It will take some time, maybe around 30 seconds. So we don't need this code anymore, since the second CPU is not booting, so it will definitely not go into the stop mode. Same thing here also. We can't wait for the second core to come out of stop mode, since it's not booting at all. Let's debug the M7 core. If I run this, you can see only the red LED is blinking, and that means only the first core is running. If we try to debug the second core, it won't work. So how do we run the second core now? We have to check the reference manual for that. Search for BCM4. Here you can see some details are given, like which core will boot. Anyway, let's search for boot C2. Here is an interesting thing, in the RCCGCR register. The third bit controls the CPU2. And if we set it to 1, CPU2 will boot, irrespective of the BCM4 value. Now we will go back to the CPU1 main file, and after everything has been initialized, we will set the bit 3 of our RCCGCR. Let's build it. Also go to the second CU main file, and comment out all these lines. We don't want the CPU2 to go into stop mode. Now I will debug with M7 core. I am in the debugger now. If I try to debug the M4, I will get the error. This is because the core is still not running. So what I will do is, I will let this line execute, and set the breakpoint here. Run it now. It hit the breakpoint, so second core must be running now. If we debug the second core, this time it will connect. So this way we can control the boot for the second core. I will leave the BCM4 on. Let me quickly erase the flash once. Before we sum up this video, I want to show one last thing. If the LCD is on, and you don't want to use it, you can turn off the backlight. Here you can see the LCD backlight is connected to pin PK0. So I will set the PK0 to output. Associate it with either of those cores, and set the output to low. Let's enable the functions that we disabled. Also enable the ones for the M4. If we want to run the code, we can simply run for the M7. As we have configured that the M7 configuration will also load the program for M4, we don't need to separately do the run for M4. As you can see, both the LEDs are blinking together. So we can directly load the program using the configuration for M7 only. If you are directly running the program, you don't need to create a separate configuration for M4. Just make sure to edit the configuration of M7, so that it can load the program for M4 also. This is it for this video. I hope things were clear. I will make more videos for Cortex M7 processors, and some for the dual core. So keep watching, be safe, and have a nice day ahead.